We'll see. Maybe not for the video. Hey, greetings and welcome, my freezing friends. Kelvin or Celsius, am I right? Page 667 was our homework last night. We were talking about rectangular and parametric equations of conic sections. So here, this was question 15. It specifically just wanted you to determine what type of conic it was, and most of those determinations are figured out based off of the analysis of A and C. So you can see that A is the 1, the coefficient of the x squared term. C is the coefficient of the y squared term. They are different, so that means it's not a circle. They have different signs, so that means it must be a hyperbola. All right, bam. Because they have different signs, and that's really all there was. Technically, then ask you to write in standard form and graph the equation. We scratched that from the assignment because we were just focused more on what was up. But in order to do that, that's when you do for a little foreshadow, when you do the double complete the square trick, as I'm sure you're all fans of, and you'd add 41 to the other side, and you'd factor out this -3. I'll just bring it at least to this far here. So x squared plus 2x blank minus 3 parentheses y squared plus 8y blank equals 41 blank blank. And you would end up completing the square. Here you would add 1 to both sides. Here you would add half of 8 is 4, squared is 16. Adding 16 in the world of parentheses was really subtracting 48. So you'd subtract 48 over here. That doesn't make any sense. Yeah, 3, 24, 8. Well, yeah, this is going to be negative over here. That's weird. Well, anyways, but that's the general strat that you'd use on that, blah, blah, blah. So let's take a look at 25, though. It says, find the rectangular equation of the curve whose parametric equations are given. Then graph the equation using arrows to indicate orientation. So trick is here. Let's see. So I want rectangular form. So I would solve them for t and substitute, although actually I guess x is already solved for t. Perhaps all we'd have to do is really just substitute x in for these, and that might suffice. So I'd have y equals 2x squared minus 4x plus 1. And in order to graph this, now you might recognize this is a parabola. You know what? Instead of doing it in standard form, I'm just going to do it in vertex form real quick because I think that's a little bit easier. 2x squared minus 2x, and then blank plus 1 blank. And for vertex form, let's see. So half of -2 is 1, all squared is +1. Adding 1 in the world of parentheses was really adding 2, but since I'm on the same side of the equal sign, I have to subtract 2 over here for my vertex form. Y equals 2 parentheses x minus 1 all squared. When you fast factor this, minus 1. So what I've got is vertex is at the point 1, -1. The value of A is +2. It opens up. Because of that, it's a stretch. You might remember that. And I guess, yeah, to graph it, you're right. I guess I put it in rectangular form. You're right. You could have graphed it with these using the table technique, picking some values for t. Which, I mean, I could graph it like this and find the path. I guess in that case, I wouldn't know which way to indicate the arrows based off of that behavior either. So let me make a little table real quick.
And what did the arrows represent?
The direction of the path over time. So let me just pick a few points here. So for x, I'd have -1, 0, 1. For y, plug in -1, -1 squared is +1, times 2 is 2, plus 4, 6, that's 7. Plug in 0 for x, that's 1. Plug in +1, that's, let's see, 1 squared, 2, minus 4, -2, plus 1, it's -1. I believe.
So putting in only 3 values for t will be acceptable if there is.
Well, you'd probably want to do a little bit more than that. I happen to have this other information that was going to help me out here, and I can use the fact that it's symmetric to figure out the rest of it.
How does the rectangular form tell you the direction?
Because the x term was squared, then I knew it was a vertical parabola. If the y term was squared, would have been horizontal. And then once I had got it in this form, the fact that this was positive told me it opened up rather than down.
Wait, can you explain that again?
Wait, can't you tell the direction from the table?
The direction of the path, yeah.
Okay.
And I guess, yeah, if I threw in another point here, I think even that would be sufficient. I think this would end up being, would this be 2 positive 1, I think? Yeah.
Yep.
Is that right?
Yes. Oh wait.
Is it 2 times 2 squares? Would be 8 minus
Is that right? Because that's going up.
Right?
Yeah, up 2 over 1. Yeah, that works. So to graph this,
I had one with negative 3. Wait, is this 25?
Yeah.
It's supposed to be negative 3. I think it is.
what should be negative 3?
The y. So, 1 and 1. That one.
Let's check it again. 1 squared is 1 times 2 is 2 minus 4. 2 minus 4 is negative 2 plus 1. So yeah, so that
Alright.
would have been negative 1, yep. So let's graph this. So when t is negative 1, I'm at negative 1, 7. 1, 2, 3, 4, 5, 6, 7. Did I count that right? I don't know. No, that looks like 6. That's 6. There we go. Then I'm at the point 0, 1. So it looks like I'm traveling in this direction so far. Then I'm at the point 1, negative 1, yeah. I keep mixing up my t values there. 1, negative 1, and then I'm at the point 2, comma 1. So this is my vertex as indicated here. Also the fact that I noticed a change in direction. It went down and then up. So there's a change in direction there, and there's only one bend for a parabola. So it looks like the parabola's path is this for my object. The direction is this. Because this was when t was negative 1, this was when t was 0, this was when t was positive 1, this was when t was positive 2. So that's why it's moving in that direction. But since they gave us values for t that went from infinity, negative infinity to infinity, the path technically goes all the way out forever. So let's see. I might take a look at one of the other ones, but I heard 33 was interesting.
Very cool. That was simple answer.
Let me let's see. Let me grab a snapshot of 33 real quick. I'm going to add this last second.
Isn't this for x equals t?
Yeah, that's what we're going to do here.
That's what I did, but at the end there was like...
Yeah, there's technically going to be, I believe there's infinitely many answers for this, depending on what you defined t to be. Chances are all of us defined x to equal t is probably what we would have done. So that's the first thing I would do is let x equal t.
And then the other one has to be...
Step 2, I then plug that in. So I'd have t squared plus y squared minus 16 equals 0. And now I could solve this for y if I want to do some fancy footwork and add 16 to both sides. And I'd get the y squared is equal to negative t squared plus 16. And now to solve for y, I'd root both sides. And I'd plus or minus, I wouldn't forget it. Yep.
You never want to solve for t.
Not in this case. I'm trying to, yeah. Y equals plus or minus the square root of negative t squared plus 16. So yeah, so these are my two parametric equations for horizontal and vertical.
You can't reduce t squared plus 16. T equals 4.
Oh, that's a difference of squares pattern, isn't it? 16 minus t squared happens to match the pattern a squared minus b squared is equal to a plus b times a minus b. Is that what you're thinking?
Just be like,
Yeah.
So A would be 4, B would equal T. If you're trying to square root distribute over this plus sign, that is first of all super illegal. You would just happen to have gotten away with it this time.
oh, alright.
But you wouldn't have were it not for those meddling kids. That almost landed.
And then something died.
Yeah, sure.
Yeah.
So plus or minus the square root of, this would have been 4 plus t times 4 minus t. But that actually didn't help us.
Simplify that and just be like y equals t.
I'm fine with this answer here. What I do want to point out is that I was thinking that for a chance, if it was equal to like a plus b all squared, then I'd be able to square root cancel. But what I do want to point out is that this actually has some t values that I think it would not work for. In fact, anytime t is beyond 4 or negative 4, I think we'd get an impossibility for the y. Yeah. Because this would be so negative that the 16 couldn't dig it out of the hole, and I'd have the square root of a negative. But yeah, the plus or minus, by the way, that occurs oftentimes whenever you have a horizontal, a non-function. So if, like, for instance, a circle or something, or an ellipse, it would graph the top half is the plus version, the bottom half is the negative version. Yeah, so this is probably some sort of ellipse or circle where it never goes beyond negative 4 or positive 4 because it just doesn't exist past there, as I think you guys would agree. But they didn't ask you to represent it. Actually, yeah, this is a circle, which I can tell now by this equation in general form, since 1 and 1, they're the same. It's a circle. So anyways, thanks for watching, internet friends. Tienen un día más bien del mundo. Bye-bye.